Hey everyone, welcome to This Explainer. Today, we're diving into the stark, honestly pretty terrifying reality of how a 40-year-old disaster has basically slammed headfirst into a modern crisis. We're going to trace a fascinating continuum that begins with the world's worst nuclear accident and leads us right up to an urgent, present-day threat involving multi-billion-dollar structural engineering and modern warfare. Since this story spans 4 decades of history, here's our quick roadmap for today. 1. The 1986 disaster. 2. The Safe Confinement. 3. The 2022 occupation. 4. The 2025 drone strike. 5. Repairing the arch. And finally, 6. The ongoing threat. All right, let's start by establishing the original problem with Section 1, the 1986 nuclear disaster. Looking at this historical timeline, we usually think of Chernobyl as an event locked safely in the past, right? Just a tragic explosion from April 26, 1986, triggered by design flaws and that fatal press of the AZ-5 emergency shutdown button. But as you can see, it's a continuum. The crisis didn't just stop. It required a massive containment effort in 2019, suddenly became an active conflict zone in 2022, and then suffered direct critical structural damage in 2025. To really grasp why regulators and engineers are sweating over this timeline today, you have to look at what was left behind. After the initial explosion, they threw up this gray concrete tomb, known as the sarcophagus, in just 206 days. It was incredibly hasty. And inside that crumbling, unstable structure, there is still an astonishing 180 tons of nuclear fuel, plus up to 5 tons of highly radioactive dust. It's literally trapped in there like a sleeping monster. And what's really wild about how the initial containment failed is how it impacted international relations. The Soviets didn't even admit it right away. The disaster was actually first detected by a nuclear plant worker all the way over in Sweden. He just walked in for a shift and set off the radiation alarms. That radioactive fallout drifted northwest across Europe, and it was that spread that instantly exposed the sheer scale of the structural breach to the entire globe. Okay, moving on to Section 2, building the safe confinement. Putting on my structural engineer hat for a second here, the contrast between that old, rusting 1986 tomb and the new safe confinement is just staggering. This new arch is an absolute engineering marvel. It cost $2.5 billion, was funded by 45 different countries, and is the largest movable steel structure ever built. We're talking taller than the Statue of Liberty, wider than the Colosseum, and it was meticulously designed to guarantee a 100-year lifespan, specifically so teams could safely dismantle that crumbling old sarcophagus underneath it. Which brings us to the modern era. Section 3, the 2022 Russian occupation. Neutrally reporting on the facts here, fast forward to February 24th, 2022, and the exclusion zone suddenly becomes an active military zone. The plant endured a 35-day occupation, and the details are intense. Defensive trenches were actually dug in the Red Forest, which is a highly radioactive area. Meanwhile, inside the plant, staff who had just shown up for their regular shifts were held and forced into continuous rotations for nearly a month without proper supplies. When it ended, offices were looted, and 6 Chernobyl workers had been taken. Tragically, they're believed to still be missing. Let's move to Section 4, the 2025 drone strike. And here is where this engineering marvel tragically intersects with modern warfare. On February 14, 2025, we saw this massive, terrifying asymmetry. A relatively tiny, cheap Russian drone, costing maybe $20,000, struck the northwest face of the arch. So you have this cheap piece of hardware that manages to severely compromise a massive, multi-billion-dollar protective shield, a shield that took literally decades of global cooperation to build. Now, assessing this from a safety regulator's perspective, the damage is an absolute nightmare. The blast punched a 15-square-meter hole straight through the inner and outer walls, about 85 meters up in the air. It sparked a smoldering fire in the rubber sealing membrane that took weeks to put out, but structurally, the real disaster is twofold. First, the radioactive confinement function, the very thing meant to trap radiation if the old sarcophagus collapses, is destroyed. Second, the humidity control system was totally wiped out. And without humidity control, that massive steel arch is now at risk of a rapid corrosion. So what do we do about it? Section 5, repairing a radioactive arch. It poses a mind-bending puzzle, right? I mean, how do you repair a highly radioactive roof? You've got this gaping hole 8 stories up in the air, directly above a crumbling concrete box that's emitting lethal doses of radiation. You obviously can't just send up a regular construction crew to patch it up. Because of the radiation, workers have a strict 20-hour annual exposure limit, so they literally cannot linger on the job site. Serhiy Terkanov, the plant's director general, pointed out that workers can only perform their tasks for maybe a few hours or even just a few minutes at a time. Think about the logistics of that. They have to flawlessly orchestrate roughly 100 qualified construction workers, doing these rapid-fire relay rotations, all while balancing way up high on a curved, highly contaminated surface. Adding to this engineering nightmare is the financial reality. 500 million euros. That is the estimated cost to pull off a full repair. And here's the kicker. They have a necessary 4-year window to do it. If they don't fix it in 4 years, the structure's 100-year lifespan is void. It just can't be guaranteed anymore. And right now, that massive sum of money hasn't been found. Finally, let's look at Section 6, the ongoing threat. Because even beyond that damaged arch, the basic daily infrastructure of the plant is essentially living on borrowed time. Since October 2024, the site has faced 4 total blackouts due to strikes on the power grid. So every time the power drops, engineers have to rely on this exact precarious emergency sequence. The grid fails, the emergency diesel generators must successfully activate, and only then can the spent fuel cooling systems maintain safe temperatures. If those generators fail, well, that spent fuel starts heating up. I really want to leave you with this final provocative warning from Director Tarakanov. He highlights that even an unintentional strike, like a drone just knocked off course, could trigger the collapse of that aging 1986 sarcophagus. And if that happens today, with the containment arch already compromised, a massive cloud of radioactive particles would release straight into the air with no safeguard left to contain it. So we have to ask ourselves, are we as a global community truly prepared to face the consequences of a second Chernobyl disaster happening under our watch? Thanks so much for joining me for this explainer, and I will see you next time.